Parth.
So good morning, everybody. Good afternoon, good evening, wherever you're from. Welcome to this is our ninth episode. We didn't even realize, but we have covered 8 episodes now, and then we're at the ninth episode of Smart Saturday Talk, our knowledge series initiative. And this time, it's pretty interesting because I personally wanted to address this for a long time. Where even in my smart manufacturing course days, uh, additive manufacturing, what is it? I mean, how does it work? How prevalent it is? How can it be more pervasive in the manufacturing sector? Why are not people too excited about this? So, of course, please join me in welcoming today Professor Parth Raval. Uh, he is an academician, researcher, and innovation leader with over a decade of experience in advanced manufacturing, quality engineering, and industry academia collaboration. This is the first time we have someone as a guest who sits on that sweet spot between industry and academia because that knowledge transfer, that tech transfer always needs to happen. He's currently assistant professor at the National Additive Manufacturing Centre West, Ganpat University, Gujarat, and is pursuing a PhD in mechanical and aerospace engineering with research focused on sustainable machining and wire arc additive manufacturing of superalloys. His academic foundation spans production engineering and CAD/CAM, enabling strong integration of design thinking, manufacturing science, and process optimization. Professor Raval has published in leading SCI index journals, including Tribology International and Sustainable Materials and Technologies, with research aligned to Industry 4.0 and sustainability imperatives. Of course, we know Industry 5.0 talks about sustainability incorporated with Industry 4.0, and Industry 4.0 itself is the fourth industrial revolution that we're all living in. He is also a recipient of the SERB Young Scientist Fellowship Award and Young Researcher Award. If someone does not know what SERB is, it's basically Science and Engineering Research Board, which is a statutory body under the Department of Science and Technology, TST. And it's established to promote and fund basic research in science and engineering. Yeah, and he has led multiple funded research and innovation projects and is a co-inventor of a government-published patent. He also brings, of course, extensive academic leadership as academic officer, MTech Additive Manufacturing, Innovation Council convener, and incubation lead. Uh, Please welcome Professor Parth Raval. Hello, Parth sir. Welcome to our Smart Saturday Talk. We're really excited to have you here. Maybe a couple of words from you before we begin.
Yes, same. I was also excited to have a conversation, have a discussion with you and the participant because, as you can see behind me, we are under the mission of Government of India. The
Yes.
organization where I belong, that is National Additive Manufacturing Centre West, under at Ganpat University. It is the initiative of Ministry of Electronics and Information Technology, Government of India, under the bigger to make the India self-reliant. So before we begin, I would like to invite everyone to approach this session with an open mind that this is not the discussion about 3D printing or additive manufacturing or rapid prototyping. But this conversation will aim to changing the way we perceive the manufacturing, right? Because
Absolutely.
each each coin has its two faces. So additive manufacturing has tremendous opportunities as well as it has certain limitations also. So where place where you are working right now, I would request you to calibrate that where this technology right suits for your manufacturing capability, and where conventional manufacturing or other manufacturing which are already existing, how they will be also suitable for your manufacturing. So it's about like to select the right manufacturing process for the right application,
Exactly.
right? So with this mind and with this new perception, let's start today's session.
Yeah, absolutely, sir. So, I mean, we normally when we talk about Industry 4.0, because I'm just going off of what you said, when we talk about Industry 4.0, we very profoundly talk about, customized and demand-driven manufacturing, which, conventional manufacturing processes may not always deliver. So that is where I think one of the biggest facets where additive manufacturing couples with Industry 4.0. But Leah, before we get into it, maybe for our audience, a brief explanation on additive manufacturing. I mean, what is the basic mechanism, and what are the different ways of or processes of additive manufacturing in a nutshell? If you can just let the audience know, then we can also then go forward from there.
Yes, definitely. First of all, we need to change what first perception for as a manufacturing into the as being the manufacturing guy, that any product in the world is assembly of different various small components, right? So additive
Absolutely.
manufacturing is able to produce small components also, and it can also produce a full product in a whole. That concept is known as part consolidation, right? But before that also, I would like to brief within 1 minute about what is manufacturing also, right? Because any product which we can see, like as I mentioned, any product is assembly of different components. So those components can be manufactured by using main four technologies or main four processes. First is subtractive manufacturing, like all types of machining. So if it is conventional manufacturing, drilling, turning, grinding, anything, or latest machining techniques like laser cutting or anything, right? So the different all the participant can relate according to their industry, right? First
Yes.
is subtractive manufacturing, second is formative manufacturing, right? Like in subtractive manufacturing, obviously we are reducing the material, so it is what we are generating the waste,
You were
right?
subtracting material from a parent material, so it's
Yeah,
subtractive.
exactly.
Yes.
But in formative, we are just playing with its dimension, right? Like
So for
casting,
formative, you mean
rolling,
forging?
yeah,
Uh,
forging, casting, and all. Because
okay.
in that, we are not going to reduce the material. Like there will, but we are just playing with its dimension, right? So
Yeah.
that is the second way. So many of the components which will be come for to at your organization for the assembly for the final product, they can be manufactured using subtractive manufacturing. They might have you manufactured using formative manufacturing. The whole adhesive industry is depending on the third manufacturing process, that is joining process. Like Favicol is used to join two wooden parts.
Yes.
Favistick Favistick is used to join two papers, right?
Yes.
Faviquick is used to join two plastic or photopolymer parts.
Yes.
Similarly, soldering is to for electrical components or all that, and the welding part, that is for metals or alloys. So they all come under that part. But we know that wherever we join any part, there are maximum chances of failure from that particular itself, right? So
Yes, that
to
is true, because the
overcome.
stress concentration is the highest at the points of joints, right? Yeah.
Yes, exactly. So to overcome like all these three conventional manufacturing technologies, subtractive, it generates a lot of waste. It requires a lot of energy utilization multiple times,
Yes.
right? Because whenever we are defining any unit price of a product, right? So on that time, electricity or power consumption or water, which is also the part of energy, it has to be considered, right? So subtractive manufacturing, formative manufacturing, or joining manufacturing, they all have their own limitations. But additive manufacturing, which is known as like Industry 4.0 manufacturing technology, it tries to overcome these limitations, right?
Yes.
Formally, if we go into the history, it has started with the name rapid prototyping. Why?
Yes.
Prototyping means first sample, right? And rapid means fast, because in the competitive world, the more you are faster to launch your product, it is you can gain the competitive advantage of the market, right? So additive
Absolutely.
manufacturing is like you can reduce the manufacturing the product layer by layer, which is one of the best term for additive manufacturing. It
Yes.
overcomes, like it will not generate a lot of waste. Rather than it produces a near net shape product,
Yes.
right? So that overcomes the limitation of the
So
subtractive manufacturing. For
yeah.
formative manufacturing, as you can see, any casting or rolling or forging industry, it requires a lot of space, a lot of heavy investment, heavy and hazardous environment for the workers also. So it overcomes that challenges or limitation of that product. And by using the part consolidation, means you can combine, you can design the part accordingly so that you can manufacture in one go. By
Yes.
using that, you can, which is possible in additive manufacturing. There were many limitations of
So
the
that is, yeah, I
conventional.
mean, one of the better advantages is that it products manufactured layered by layer with
Yes,
deposition or addition does not necessarily have joints. You can have the whole topology of the product made in itself. Although you can
yes.
have a final product assembly, but still the minor assemblies are eliminated, right?
Previously, it was not possible because, like, you have to manufacture the part, but you have to make a trade-off between the part manufacturing and its unit price also. Right.
Yes,
So we can, if, with the help of conventional manufacturing, you can produce those parts. Not an issue, but it will not land into your economic, right? So, but with the help of additive manufacturing, definitely you can go with that. So it will give you all the added advantages of the over the conventional manufacturing technology. Yet, as it is under some research stage also, and the adoption within India, out of India, there it has been well adopted. But within
absolutely.
India,
Yeah.
it is at the group, like we are at the acceptance stage. And once the acceptance stage will be there, people will start accepting it, right? Then people will start to adopting this as well.
Absolutely. So, I mean, so additive manufacturing, or let's just call it 3D printing for the sake of a easier name. I mean, I think it has three main processes to deposit layers. I think it's one of them is stereolithography, of course, where you cure the resin with UV light. And then there is fuse deposition, I guess fuse-based
Model.
fusion deposition. Yeah. And the third is powder sintering.
No, like I'll correct it only. As
Sure.
per ASTM standards, there are totally 7 established additive manufacturing processes based on
Okay.
input material, its process physics, and output. If we divide the whole manufacturing chain into three parts, like before manufacturing, during manufacturing, and post manufacturing, we know that we need the solid part itself. So output will be always solid part. But for
Yes.
input, it can be three options. First option is in terms of solid, like it can be plastic wire or it can be
Yes.
electrode like which we use in the for the welding processes, right?
Yes.
Second can be in the liquid form, and its technical name is resin,
Resin.
right?
Yes.
And third one is in terms of powder form,
Yes.
right? So the 7 established technologies as per ASTM standard are material extrusion, the name which you just spoke, FDM, fused deposition modeling. It is the
Yes.
patented technology of Stratasys, a US-based MNC. So right now, it is the only one company which can use this technology because it is patented. If any other company, any tool manufacturer who manufactures the material extrusion machine tool, they have to use the fused filament fabrication word, right? Another technology is wet photopolymerization, and
Yes.
its well-known technology is SLA, which you already spoke, stereolithography,
Stereolithography.
right? But it is
Yes.
the subcategory of the technology. The parent technology is wet photopolymerization, where
Yes.
liquid resin will be used, right? It will definitely give you a good aesthetic look, but there can be chances that it may give you strength, or it may not give you also, right?
Yeah.
So third and fourth technology are related to the metal additive manufacturing, powder
Yes.
bed fusion and directed energy deposition. These two are
Yes.
the metal additive manufacturing processes which are generally used or well adopted by aerospace and automotive and rest heavy engineering companies, right? And rest
Absolutely.
three, like first is metal extrusion, then wet photopolymerization, powder bed fusion, directed energy deposition, binder jetting, material jetting, and sheet lamination. These seven are well established technologies, and that too as per ASTM standard.
Yes.
So
So I mean,
any
yeah, from whatever from what you have said, it can be really surmised that the choice of the material is not a limitation right now. You can build even metallic products with 3D printing. You can build
yes,
plastic products with 3D printing. You can build certain polymer-based products as well with 3D printing. Right. So
all non-natural materials can be 3D printed. I would say in a one line, all
yes,
non-natural materials, photopolymer, they are non-natural, right? All
yes,
types of metals or alloys, they are non-natural, right? What
yes,
is natural? Wood. We cannot do the 3D printing of wood, right? Because
yes.
it is natural. We cannot manufacture the woods,
That is a good
right?
point. Yes, yes,
Yeah. So there are multiple options available right now for the 3D printing in terms of its material input and process, because the parameter needs to be set accordingly as per the final geometry and as per the material which is there as an input.
yes. Also, I mean, but the basic philosophy
Should
remains the
I,
same.
like, there is one question, should I also answer simultaneously, or we will address these questions
Sir,
afterwards?
yeah, we have a dedicated like 10 minutes at the end of the session to take the questions. So it would be
Okay,
best if you can just take the questions there. I'd like to
definitely.
thank, yes, absolutely. I'd like to thank Mr. Yogesh Kumar for the question. Please stay tuned. We'll answer your question in the last 10 minutes. Thank you so much. Thank you so much for the
Definitely,
question.
definitely. We'll definitely answer this question. I'll give you one of the example also of
Yes.
this question. Sure.
Yes, we look forward to questions actually, because otherwise, I mean,
Yes.
it is a platform for the audience to interact with you directly as well.
Yes.
Okay. So, but the basic philosophy remains the same, right? It's layer by layer addition, and you're not subtracting metal from a parent part. So you're
Yes.
essentially minimizing wastage. You're essentially making tooling costs lower. You essentially
Yes.
just have, one. So a basic flow of additive manufacturing process would be a CAD/CAM model, and then you export that to your 3D printer, and then the 3D you adjust your settings based on your requirement and the material, of course, and then you just press a button. Isn't it that simple, sir?
Yes. I will just realign it.
Yes,
You are just like mention it right. But I will say that any product which we are going to manufacture, that means we are doing that process because there is a need of that product or component. If there is
yes,
no need, we are not going to manufacture it for sure, right? So based on need, what science or what scientific research says, that when there is a need, there the need must be specific. So based on that specific need, the specification of that part or component or product must be
and the
there.
design itself.
Yeah. So based on that design, that specification design is to be prepared. So
Yes,
if you see the value chain, based on need, specifications are there. Based on specification, you design the part, right? After designing, you try to optimize it at the design stage itself. You try to
yeah.
analyze it.
Is
Yeah,
it
you
something
try to
called
analyze.
topology optimization for that?
Yes, exactly. You
Okay,
try to analyze the product also, right? And now there is a much more facility of simulation also. You can simulate
exactly.
the product before manufacturing. So in conventional manufacturing and additive manufacturing, the stages till design, analysis or simulation remains same, right?
Yes.
But it changes afterwards only, because in conventional manufacturing, you will go with the die or mold, right?
Yes.
Generally, based on the material, based on the complexity of the design, the die manufacturing will cost you around 5 lakhs, 10 lakhs. It depends, right? But
Yes.
in additive manufacturing, there is no need to go with the die manufacturing. So ultimately, you are first saving your that investment of 5 to 10 lakh rupees. And on the other side, as I mentioned first, each coin has two sides. So first, you are saving the money for that, and secondly, you are getting the added advantage of trying multiple designs, because
Yes. The
if you fix
iteration
one
cycles are so
design with
shorter
one,
now.
yeah.
Mm.
So if you design only one product, right, you just have to build one die, and then you have to stuck with that itself. If you have some mistake or error in the design, that die will no longer be useful for you. But for additive manufacturing, you can experiment n number of designs, because there is no need to go with the die. Instead of that,
Yes.
there is a slicing process. There are multiple slicing softwares available. Some are open source, some are to be subscribed. Some you have to pay the money for that. And that
Yes.
those slicers do two things. First is slicing process. Like whenever you see our mobiles or any displays, when there are more number of pixels, we call it a good resolution, right?
Yes. Yes. Exactly. That is
Similar,
a perfect
similar,
analogy. Yes. Uh-huh.
yeah.
Agree.
Similar is with this technology also. The more the layer, right, the more the addition, or the more it will be look good as per the strength or as per the look also, right?
So basically,
Accordingly,
more the number of slices, better the surface finish.
it can be one of the
Okay.
possibility, because accordingly on this in the second stage, like a tool path programming is to be done, right?
Yes.
Like we know that for CNC machining, we need to use G codes and M codes. By
Yes.
using those G codes and M codes, we are doing the part programming. So within the slicer, there are some algorithms which do this process for us. Like you will get like 1 lakh or 2 lakh or 5 lakh lines part programming within fraction of
Yes.
second by using these slicer softwares. So, and there is no investment in that,
Exactly.
right? So,
Exactly.
and after that, they've again merged that we have to manufacture the part. And
Yeah.
after manufacturing the part, some post processes are always required, right? Before
Yes.
delivering the product to the end user, right? So first
Yes.
advantage
So,
is like there is no need for the die manufacturing. So external dependency is also reduced for the manufacturers.
also that this is where I'd like to add a point where, because mold and dies in an injection molding or what in a process that requires a mold or die, it is also one of the major costs. And companies and facilities have spares kept so that they don't miss out on production, right? And if for certain reasons sometimes spares are not available, or even for the spares to be available in your inventory, the logistics that the logistic time is so high. So the mold doesn't just come with the cost, it also comes with the cost of time that it takes to acquire the mold. Also, if you do not want to have this logistics factor in your whole value chain, then you can also manufacture it in-house. But then also it takes a certain time to manufacture that mold to be able to manufacture products off of that mold, right?
Yes.
So additive manufacturing, in my understanding, would just completely eliminate that.
Yeah, it will like definitely you can say it will eliminate.
Yeah, so it's basically a debate between volume driven production, where you have a good accuracy of forecasted demand based on the kind of business you have, versus customized demands. So, and also it also might not always be customer facing in a way. Okay, if the customer wants a customized product in a certain way where it's not, or it's hard to acquire the mold, to acquire the appropriate pieces to even manufacture it to conventional manufacturing, then we can just have it through additive manufacturing. But also in functions of the production facility itself, for example, I see around a lot of examples of additive manufacturing used in NPD, right? And that is where it develops and it provides a lot of value where your iteration cycles so that is where the rapid prototyping phase comes into the picture. Because to prototype, you're just waiting for a CAD/CAM model, the slicing software, your need you have your specifications, your CAM mod, the design based on that, and you have already a 3D printed part ready to be prototyped, ready to be tested, and ready to be iterated. But if you want to have design changes in that, it's really easy and flexible to do that in the CAD/CAM software. But imagine if we have to acquire another mold based on the design change just to have a product iteration and product testing.
And you have to store
So
it also as an inventory.
yes,
You have to, and that too in a protective manner. So I'll do, I mean, whatever you mentioned, I'll summarize it in one word only: mass customization. That's it.
mass
The more
customization,
you,
yes,
yeah, mass customization is the best benefit of additive manufacturing, right? I'll give you many of the examples also, like Lenskart, one of,
please, yes, yes,
right? Lenskart, they have adopted additive manufacturing technology from last 1 decade. So just imagine before few years, before COVID also, right? They were giving that idea that you just scan your face in their on their website and select the frame, they will deliver you. How it is possible? Mass customization. They are
yes,
using 3D printing technology. From last 1 decade, the jewelry making, big brands of jewelry making, they are also using 3D printers, especially for jewelry, because the more the complex the jewelry design is there, the more the jewelry maker can cost it, right? Can get
yes,
the money for it. So, and that much precision can be achieved by the human, but not within the last time. Or the person will also ask for more money. So what about
yeah,
the profit margin of
yeah,
big brand jewelers, right?
yeah.
So already there are many machine tool manufacturers who are available in the market, who are dedicatedly designing the machine tools for specifically for the jewelry industry,
Yes,
for some other FMCG products, right? Based
yes,
on their requirement, based on their design. And if you see the whole market, the value chain also, then any manufacturing, because manufacturing will start with the tangible product itself, right? So it starts from raw material like extraction, its purification, then we get some material, we manufacture it. After manufacturing, some post-manufacturing processes are to
of
be
course,
done,
yeah. Mhm.
then packaging and some other processes, and then you deliver it. And after delivery also, you have to like, if you want to follow the sustainability concepts, right?
Yes,
Then we can opt for the circular economy. So it has to be recycled, reuse, right? We can
yeah,
term it either all five are, or partially, right? So some material importance is also there, that we need to club into this.
absolutely. I mean, we are moving towards more in a world where sustainability is for all the nations and for all the hemispheres as well, for all production facilities, for all businesses. It is becoming a major factor to consider because we are moving towards that. And this circularity where I think it also talks about, gate to grave or grave to grave kind of circularity,
Yeah.
where you have the entire product lifecycle management. Uh, and additive manufacturing would certainly help with that because just because of the wastage amounts, the scrap, the material spillage, the kind of materials that we can use, recyclable polymers,
Exactly.
etc. So it kind of opens
And
the door into that whole sustainability index for everybody who wants to participate. And of course, give their brands a competitive advantage.
that's why my PhD topic was accordingly, like sustainable machining and its life cycle analysis for additively manufactured Inconel 625 alloy. Like
So
Inconel alloys are always known as super alloys because
Yeah,
Uh,
I know
they
about
are
Inconel,
hard
but
to
so
machine.
we can also, I mean, we can, I mean, 3D print Inconel 625 right now.
Yeah,
Wow. Okay,
with the
I
help
did
of
not
warm
know that.
technology like wire arc additive manufacturing, which is one of the metal additive manufacturing under directed energy deposition. As I mentioned, there are 7 categories
Yes,
of
yes.
additive manufacturing technology. So under directed energy deposition main technology, there is one technology which is a welding based metal additive, WAM. In that also, there are three
Okay.
kinds of GMAW, GTAW, and plasma arc welding based. Right.
Yes.
So in under that GMAW, I had utilized the setup of GMAW based wire arc additive manufacturing to produce the parts. Then its machining processes were carried out. Some machinability parameters were evaluated, which are related to the sustainability, like power consumption.
Yes.
It directly relates to the carbon footprint. So it adds
Absolutely.
to the life cycle. And after all this life cycle analysis, cradle to gate were also uh, performed using some of the LCS softwares.
Yes. Yes. So, I mean, how does, for everybody to understand in a simple language, maybe if they cannot build a connection, how does sustainability get into the picture of additive manufacturing? I mean, of course, we talked about recyclable materials, but how does it actually help in the life cycle analysis? And I mean, why does sustainability go hand in hand with additive manufacturing? If you could just
Like
briefly.
generally, sustainability has its three pillars, right? Environment, economic, and social, like health, right? So sustainable additive manufacturing means, as I mentioned, that you need not to work in hazardous manner, right?
Yes.
So there are the social that the third pillar, social, will be preserved for you, right? You can produce the parts very effectively, and that too in a safe environment. Second is, like, suppose that if I make one cube by using casting or forging, I'm utilizing energy one time, that too at a commercial rate,
Yes.
right? Second time, I will go with the rough cut, like machining, rough cut.
Yes.
Second time, energy utilization, that too at a commercial rate.
Commercial rate. Yes.
Third time, I will go with medium or fine finishing machining, like grinding or polishing and all. So third time, I'm utilizing the energy at that to at a commercial rate. And then
Yes.
comes either coating or something, because whenever there is any metals or alloys,
Something
we
passivation is required sometimes. Yes.
yeah, for corrosion resistance and oxid means to prevent or reduce the oxidation rate, right?
Yes.
So just imagine that you are utilizing an electrical energy three times, right? For conventional manufacturing, that too you are adding three. Like first is formative manufacturing plus subtractive manufacturing plus like joining or something, right? Rather
Yeah.
and that too at different locations. So transportation will be also there,
Yeah.
right? So transportation will also add the carbon footprint in the environment. So rather than that, if you can get a near net shape product at the one place itself, what how it will be? Because it will consume only one time electrical energy, so less carbon
Yes.
footprint, right? You will get the added advantage that you can design it accordingly.
Hmm.
And the more the complex design, the more has additive manufacturing its application, right?
Yes. Yes. Yeah.
So in
Yeah.
a way, it will definitely give you that advantage, because like the top management of big companies, they are also concerned about how to perform, how to match the business objectives and simultaneously producing more means increase productivity, right? Reducing cost, and that too with like uh, aligning with the sustainability goals. So
SDGs.
this
Yes. Yeah.
technology will definitely help them. I'm not telling that not anybody who is into the additive manufacturing will ever claim that it is going to replace the conventional manufacturing. No, no
Yeah.
one is
Yeah.
going to replace anyone,
It's
right?
an
But
enabler of
yeah,
sustainability.
it will complement the different manufacturing technologies.
Yes.
Right. And we always, whenever we go for any trainings or whenever we go for any talks also, we always try to say or convince the person to change their perception, like that additive, by using additive manufacturing, you are just going to get a mass customized product, lesser volume, high
Yes.
value, because you are customizing it, so it is high value, right?
Absolutely.
That where by utilizing the minimal material,
High
minimum
value
time,
at the least cost of production.
low volume, high value, less material wastage, and that too within less lead time. That
Yes.
is the biggest advantage of additive manufacturing.
Yes, true. So I wanted to move on to this segment where we talk about where exactly industries has been really been accepting it, and what has been the challenges recently. But I mean, first, let's just, if you can briefly talk about the latest cutting edge developments that is happening in the academia, because whatever happens in the academia takes around, 10-15 years to be commercialized into the industrial space, or maybe right now a bit lesser than that. But talking about Industry 4.0, Industry 4.0 talks about mass customization, or the ability of processes to cater to mass customization requirements, right? And we see sometimes requiring less material. For example, let me just give an example of this uh, uh, SpaceX Raptor engines. So the internal tubings that is required to have the most efficient and least material wastage with the highest yield efficiency of materials efficiency, yield percentage of materials efficiency. It's impossible to have internal tubings and the kind of complex design that these engines have with subtractive manufacturing. It's not difficult, it's literally impossible, which then additive manufacturing is just its playground, right? And it happened with the same with Skyroot's Raman 1 engine. It's 80% 3D
That is
printed.
part consolidation. The
Yes,
concept of part consolidation. That rather than like, otherwise you have to weld it by
yes,
you
exactly.
manufacturing all these parts differently, and then you need to weld it. But rather than
Yes.
that, you can design it. That is parts consolidation. And as I mentioned, that like after 3D design, you can analyze, you can simulate it, right? And then you can manufacture that part. And there is no limitation for the material as well.
Yeah, I've seen like
Right?
videos of whole ship's hull being 3D printed. I've seen
Yes.
videos of, walls, I mean, building walls being 3D printed
Yeah.
layer by layer. So is
Yes.
carbon
It
fiber?
answers it answers that, like, there was one question, that is it of 3D printing in concrete available? Yes.
Yes, yes,
India has
yes.
done its first, like in 2020. You can Google it also. You can see the videos in on the YouTube also, that the post office building of Bangalore was manufactured using 3D printing technology in 2022. So India is also well ahead in that. Another one of the big good startup, that is known as 𝐒𝐚𝐭, MICOB. It is a IIT
Okay.
Gandhinagar based. Three students have started this startup, and till now they have delivered 500 trial and tested bunkers for the Indian Army. So
Yes, this is the video
that
that
is
I saw
also
where,
possible.
yeah, in the higher altitudes, you cannot, it's very hard to actually physically carry materials up there to then assemble. But if you can just have other 3D printing
Exactly.
component, the machine there, you can just have it added layer by layer and build it up. Yes, yes.
Yeah. And you might be like, now we you or me might have seen many a times that whenever there is a road construction in process, right? They will manufacture that cement concrete mixture nearby only,
Yes.
right? So additive manufacturing, if we relate it with the additive manufacturing will give you a localized production facility,
Near
right?
to the point
Then
of use. Mm.
if you have 3D printer at your location, you can manufacture that part at your location itself. So no transportation cost, no transportation carbon footprint, no lead time. You can definitely manufacture those parts at
Literally, I
your
mean,
location.
you can probably just email the CAD model to them and they can just
Exactly.
print it
And
out and
that's
give
why,
it to you.
yeah, and that's why marine applications has many adoption of these metal additive manufacturings, because we know that whenever any sea starts sailing into the sea, they have to go with multiple machines also, like lathe, conventional lathe machine, drilling machine, and all, because they are not going to get any support with it when they are into the sea, right?
Yes.
And suppose that due to some uh, any clash or any incident, if a major part of that ship is broken or break down, they
It
have to
requires replacement of
they have to
spares.
come to
Yeah.
the back to the sea. The name
Yeah.
that concept is known as decarbonization, and additively manufacturing directly supports the decarbonization concept, because there is no need to go to back to the sea, to the shore, for just for the maintenance purpose. There is another
That is so
maintenance,
true.
there is another concept of MRO also, maintenance, repair, and overhaul, right? So many of the persons can research or get a startup, or can they look a new perception of their business into MRO field as well, right? That localized or that on-site maintenance, repair, or overhaul facility will be given.
Yes, I mean, you don't need to have multiple SKUs of spares available with you. You can, whatever is required, you can just print it and use it.
Yes, exactly.
Yes, that is very, very cool. I mean, but sir, I mean, if you talk about in the manufacturing sector specifically, where we the products ranges from FMCG to cars, automobile, casting, etc. Uh, I mean, what is the acceptance rate of 3D printing in those scenarios? How much has the companies and the facilities accepted it? And if they have, where are they using it? And if they have not, what has been the challenges?
No, like you have already answered these two questions. I just need to refine it only. Like we know that if one kg of like any airplane is its weight is in tons, right?
Yes.
So if we utilize the additive manufacturing to manufacture any part, either any small component by
Hmm.
topology, by utilizing topology optimization to reduce its weight, that is first
Hmm.
option. Second, if we go with the part consolidation, and if we can reduce at least 1 kg of the weight uh, over its total lifespan, it will give you multiple time benefits in terms of fuel efficiency, in terms of the carbon footprints, all, right? You can go
Yes.
with more cargo or more passengers, because that balance needs to be there,
Yes.
right? So this is the additive manufacturing is well accepted by the aerospace industries and all those industries which are of high value, right? Like you can say automotive also. It is
Yes.
well accepted in pharmaceutical also, healthcare, like mass customization is the, like if I give you the best example of mass customization is related to different prosthetic or orthopedics or dental application, dental aligners.
Yes.
Each one
Yes.
of us will have different, may need different aligners, right? So it is mass customization. So it is already accepted by them out of India and within India also.
Yes.
Right. So it is well accepted by aerospace industry, by topology optimization, and the part consolidation aspects.
Yes.
Any, like whenever same is with the automobile also. If we can reduce the weight, like previously the bikes or any cars were manufactured by using the steel or some steel or alloys, like metals or alloys. Now it is being manufactured by using carbon fibers. Why? To reduce the weight. The more means the lesser the weight of that component, the more efficiency can be, or fuel efficiency can be achieved.
Achieved. Yeah.
So by just if you though the manufacturers were focusing on the material part, like they were replacing the material only rather than using steels or alloys. They are just using the composites, because carbon
Yeah.
fibers are the categories of
Composites.
composites,
Yeah.
right? So eventually they are landing up onto the additive manufacturing, because in that they want some fancy designs also to reduce the air friction and other parameters, right?
Yes.
So the 3D print, it has well accepted in aerospace, it has well accepted in the automotive, it is well accepted in the jewelry making, FMCG products, like glasses or monuments, right? The whole sculpture of any person. We are doing providing the consultancy services for that, right? Being
Okay.
the
Yes.
national center for we are also delivering those services. So, another is in terms of this jewelry making, construction, all you name any field, it is applicable to healthcare, all healthcare and industry, electronic, pharmaceutical also, right? Based on the severity of the processes or the product, the material is to be selected,
Yes.
right?
That's
Like
the critical part.
if you heard about this FDM technologies, you might have heard about it material, ABS, PLA, PETG, ASA, right? These all are photopolymers only, but with
Yes.
different categories. Like the if I want to manufacture if I want to manufacture a part which is an internal part, I can use ABS. But if it is to be utilized for outer applications where some UV
Yes.
light or some other radiations are there, I just need to replace ABS with ASA material, right? PLA is
Yes.
very beginner friendly if you are, and cheaper also, right? So it is not always required that you go with the higher end materials
Hmm.
only, because what we understand about any material is either any component may need either strength or aesthetic or both. Some
Both. Yeah.
structural part, they will need strength. They are least
Yes.
concerned about the aesthetics,
Yes.
right? But some elevated parts, like if you see any parts elevation, then you think that no, it must have good elevation, right? Some good aesthetic. So in that, strength is least, right? It strength has
Yeah.
least importance for that. And some parts, those are assembled or some are utilized for some high value operations. They may need both strength and the appearance, like
Yes.
aerospace or space parts.
Yes. It's
They may
basically the
need
finish
both,
of it. Yeah. Hmm.
right?
So
So they may need
one
both.
of the use cases I saw was, I think, I mean, of course, it was in a Chinese factory. They were actually making the molds itself with 3D printing. So it was 3D printed molds. Of course, depending, I mean, they're selecting a certain material that can withstand the injection pressures and stuff, the compaction pressure, injection pressure. But it works for them, and it literally you don't have to order molds. You can just literally have for your new products. You want to test it out. You don't want to test out the mold itself before you apply for or order a mold for your conventional mass production. You want to test out the if the design itself works properly, and they
Yes,
3D print the mold. They just set it on the jigs and the fixtures of the injection molding faces itself, and they continue with their product at the testing iteration. So that is
yes,
also one of the use cases that I saw. But sir, what are
yes,
the? I mean, yeah, I mean, if you talk about limitations, I mean, this probably would be one of the last questions. One is, what are the limitations? You can just talk about it briefly, and then thirdly or lastly, uh, the digitalization aspect of it. How does it connect? I mean, the industry 4.0, uh, how does it connect with additive manufacturing? Why is it one of its three main pillars? So if we just first talk about the limitations and then end with that question, and then post that we can take the questions from the audience.
yes. like for the limitations of additive manufacturing is like you need to be competent in terms of its process parameters, right? So a
Yes.
capacity, like it is not like you just get a order a 3D printer, like it is already available in the market of 50,000, 1 lakh, 2 lakh, depend because it will also give you that much precision of that provider, right?
Yes.
Of that product. But it is not like you just order a 3D printer and you start manufacturing it. It is like you are
Yeah.
just using the chat GPT for ordinary objectives, right? It is not
Yeah.
like that,
Yes.
right? It
Yeah.
has its bigger potential. So additive manufacturing, any technology of additive manufacturing, it has its bigger and you like unbelievable potential. So you just
Hmm.
need to understand what are its process parameters, how you can how you can uh, design it, or how you optimize it. Like
Yes.
for so like it is not like you just plug and play, right?
Yeah.
You need to understand. And first of all, being a decision maker of your company, first you need to understand that whether this is advisable for you, for your product or business objective or not, right? It is not always
Yes.
that you adopt the fashionable technology. Additive manufacturing is industry 4.0 technology, very trending. But first of all, you need to calibrate that whether
To your
it is
business
aligned
case
with your
itself.
business objectives or not, right? If
Yes.
you are a service provider only, then there is no need for the 3D printer, right? If you are just service provider, because your main work is service to provide the service.
Yes.
But
Yes.
and similarly is if you are just assembly, like doing the assemblies, right? And you are ordering, you have your green supply channel, right?
Yeah.
Why to bother it? But if
Yeah.
you have some low volume and high value products requirement, right? And there is one terminology in the manufacturing industry that is known as MOQ, minimum order quantity, right?
Yes.
Though you suppose that if you require 120 parts per year in your part assembly, right? Still, once the manufacturer has made that die, he or she needs to manufacture at least 500 or 1000 part to match the unit quantity, right?
Yes.
And he or she will also force you that though you need 120 parts per year, right? Still, you have to purchase at least 300 parts or 400 parts or 500 parts
Yes.
from me,
Yeah.
right? So
Just
that is
because of
minimum
the.
order quantity. So you additive manufacturing will break that, right? There is no need to invest in for more parts. Second, once you order those parts, there is a pile of inventory at your organization. So you have to
Yes.
store it,
And
right?
that, of course,
So
that
there
comes
is
with a
no headache for
cost.
that
Yeah.
storage of inventory also,
Hmm.
right? So it will give you that advantage also. But there are chances that on that like the materials which are used for the additive manufacturing, they needs to be stored at some controlled temperature. Like
Okay.
if you have for transformer industry, they need that should not be, or there must not be dust in that particular area where any winding process, like for transformer winding process or some other assembly processes are being processed, right?
Yeah.
So like similar is with this technology also, right? It is like in nutshell, I can say it is a very niche technology that it
Yes.
requires some controls temperature or controlled situation where it performs the best, right? Otherwise, like for photopolymers like that FDM or triple F process,
Hmm.
if if we keep the material out of that comfortable or that controlled environment, it will absorb some moisture.
Yeah.
And if we are going to give it as an input, if the input has its defect, definitely you
Then
will
of
get a
course, yeah.
defective
The
product itself,
yes. Yes.
right? So some controlled temperature, controlled, and first limitation is it must be performed under some controlled situations, or the
Yes.
materials needs to be stored at some controlled environment. And second is like uh, it is also equipped with some most of the patented technologies, right?
Yes.
So you need to be agile also to gain more profit. Though
Yeah.
you will be definitely able to give competitive advantage, you will get the competitive advantage, but still there are some of the technology, there are advantages which you needs to gain, right?
So when we talk about, so for example, digitalization talks about the extended use of software, data, sensors, etc. So when we couple that with additive manufacturing, is it
Yes.
basically okay? So we have a digital model. We can run a digital twin testing of the digital model, and if it works, if the feasibility study is okay, approved, we can go for physical product testing, which where the additive manufacturing part then comes in, because you're directly exporting the CAD model. Of course, you also do it with CNC, where you generate the part program, but you're also minimizing, as we mentioned, we are minimizing multiple costs that comes in between, to have the product iteration cycles shorter and shorter, so that you can have more number of iterations in a given time as compared to conventional manufacturing. Am I correct on this? I
Yes,
mean, that is where the
I
industry
just make it
digitalization
inline.
and additive comes in.
Yeah. Like suppose that you have an additive manufacturing machine tool of any one
Yeah.
technology. So you will need more, you will need some data, right? If you want to digitalize, or if you want to get more added advantage. So
Yes.
whenever you need data, we know that sensors must be there, right?
Yes.
For like thermocouple for temperature measurement, and some
Yes.
other, like likewise. I just give you one example, right? So you can, there is a lot, means a lot of research is being conducted right now in this element, that what if we integrate sensors which will collect the data, right? AI which will produce the large language models based on those data, right?
Yes.
And with third is the digital twin, that whatever the processes is being produced, or is carried out in the additive manufacturing, that machine tool, how we can digital twin it to continuously monitor it. If there are some discrepancies, right, we can we can correct it also automatically, or by some commands, or afterwards also, rather than we letting the defect to occur,
Yeah.
right? If we can stop defect
Absolutely.
occurrence, or right, that is also one of the best technology, or best research being, and who knows that within a couple of years we can have some machines which integrates these things also. Right now also many of the sensor based additive manufacturing machine tools are also there in the market, but its integration with AI and digital twin, it is about to be done. So it is one of the good research topic
Areas right now. Okay.
for the researchers, for the practitioners also, and for the
Yes.
industry, that they can definitely get this technology, these things,
Yeah.
right?
So have, practical innovation cycles in the industry themselves.
Yes.
So yeah, I mean, I think we have wrapped up quite concisely on everything that is additive manufacturing, where it comes into the picture for conventional manufacturing industry 4.0 as well. I mean, we are obviously overshooting our time a bit. So thank you everybody who have been listening to us, and then for your questions and your comments as well. It has been really, really great to see that. One of them, so Mr. Naresh had asked, I mean, let's just take some questions here and then we can wrap it up.
Yes, yes,
Well,
sure.
Mr. Naresh had said, how about pharmaceutical? Some examples. So I think one, I mean, we talked about 3D printing with concrete. So I think Mr. Yogesh Kumar's answer, question has been answered. So it is possible. And we, of course, have, you have given examples of the post offices and the Indian military barracks. For Mr. Naresh, how about for pharmaceuticals? Some examples. I think you have also talked about the dentistry part of it. Are there any other use cases in pharma that you know?
Sorry, are there?
Are there any other use cases in pharma for additive manufacturing?
Yeah, like any testing phase, like any pharmaceutical industry may need multiple testing phase. They have multiple testing stages, right?
Yes.
And you for to perform those stages, they need to use what single time equipment, right? So multiple biomedical or biomaterials are used, are there, right? Which are also can be called as smart materials, and they can be 3D printed, right? Which are
Okay.
recyclable also. So by using biomaterial for pharmaceutical applications for testing or some implants also, right?
Yes.
Like pharmaceutical, they when they are producing the drugs, right? It has to be tested multiple at
Yes.
multiple stages. So it can be possible to go with that
Yeah. Okay. Okay.
biomaterial plus additive manufacturing, and that too in a circular economy.
Yes. Uh, so someone from Mahadev Precision Cast had asked, can casting produce 3D models? I'm not sure if we understand the question, but I think it means uh,
Generally,
if
like
casting can also if
generally
casting can
all
also
products in the
produce
world are 3D only.
3D, yeah, 3D models. I mean, what advantage additive manufacturing gives, of course, is obviously mitigates the risks, the kind of high temperature environments, the requirements of the molds, of course, the logistics associated with it that we all talked about in this session. So I think that is okay. Any service provider. So do you know of industrial additive manufacturing service providers uh, uh, from your experience?
Uh, there are multiple service providers. Like STPL 3D is one of the indigenous service provider, right?
Okay.
STPL 3D is a Surat-based company, right? STPL, there was one company, STPL, from a long time, but they have started
I think
into the
STPL
additive manufacturing also.
excelled in laser cutting and laser
Yeah,
place
they were the
fabrication, right?
same one,
Yes. Okay.
right? They were into this business from long time, but they have started additive manufacturing facilities
Mhm.
also, right? Why we also why I say their name also, because like under this additive manufacturing, like under this National Additive Manufacturing Center, we have also
Mhm.
supported this and industrial this Indian-based startup for 3D
Yeah,
printing,
because
right?
I read about the institute a bit. The whole purpose of the institute is to bridge that gap for additive
Yeah,
manufacturing,
like
specifically
this,
between the
and
industry and the
yeah,
research.
this
Yeah.
like India has its broader mission, which is known as National Strategy for Additive Manufacturing, right?
Okay.
And under that mission, Ministry of Electronics and Information Technology, Government of India, has established 7 different center of excellences, like you can say research and training center across
Hmm.
India. And we are one of those 7. The National Additive
Okay.
Manufacturing Center West, which is located at Ganpat University. And we are always introduce ourselves as like ecosystem enabler for 3D printing technology with a purview of 6 states of Western India. So we develop the whole ecosystem, right from school going children to colleges and industry within the western part of India, covering 6 states: Punjab, Haryana, Rajasthan, Gujarat, Maharashtra, and MP. And
That's a great initiative. Hmm.
the main objective is to develop indigenous product and indigenous processes,
Yes.
alignment with the government of India's broader mission.
Yes.
So
Thank
I
you.
like
Yeah, that
with
was
your consent also, I would like to request all the participants also, wherever that you find any possibility, you do visit our center, like, right, because it is the government
please,
of
yes,
India
yes.
research center. Maybe we can help you out because we are also on a national mission, right?
Yes, yes.
And
It
thank
has
you,
to be a
your team
collective
also.
effort. It cannot be isolated effort. There has to be
Yes, yes,
acceptance, and there has to be demand and supply, as we say in economics, right? So you
yes.
have to demand for it. Only then will the supply will be robust, so to say. Thank you everybody for I'm really sorry if anybody else had questions. If you have any questions, you can send it over to us. We will, of course, get it answered. It could range from anything basic to anything that is on your mind regarding this topic and this conversation that we had today. And of course, a big thank you to Professor Parth Raval, sir. And the insights has been great. The conversation has been great. We really had fun. Thank you to all the participants as well. Thank you to uh, uh, the participants that stayed with us till the end of the session here. And it's time to land this plane, as we call it. It has been a great session, a great conversation. This has been Smart Saturday Talk. Thank you, sir. If any last words before we end, and that's it. Any last
Yes,
words from you, sir?
yes. I'll just request all the participants and their like their company stakeholders also that do not consider this 3D printing or additive manufacturing technology as a technology, not only just fascinating technology to adopt for quickly. Rather than you try to integrate this technology for your business objectives. If it is good for your business objective, then only you should go with it, because any business objective will have three things: delivering the product, that too at competitive rate, and that too with minimum hassle of manufacturing. So if additive manufacturing is giving you all these three, then definitely you should go with this. Otherwise, many of the times we have seen that company starts adopting this technology. It is not to be adopted; it is to be integrated, and that too if
Yes,
required.
yes, exactly.
Okay, sure.
Yes,
And
exactly.
all the
Yeah,
best
that is
wishes for to all the
that is.
participants.
Thank you. That is perfect message to end this. Thank you everybody for joining. Thank you. We'll see you. We'll look forward to seeing you in the next our next Smart Saturday Talk episode as well. And as always, this episode will be live on YouTube in a couple of days. And anybody can share that with them, share that with their colleagues, their friends, their families, anybody interested in the topic, anybody who wants to revisit our conversation, they are welcome to do so. Please be on the lookout for that as well on our official pages of Concept Business Excellence. And yeah, thank you so much. Thank you. This has been a wonderful session. This has been Smart Saturday Talk. We'll see you next time. Thank you.
Thank you.